Welcome back to our channel Maths by SRAVAN VATAMBEDU. If you are watching our channel first time, please do subscribe to our channel. And in this video lecture, we are going to discuss about
numerical integration. So in numerical integration, we are going to evaluate this one. To evaluate integral a to b f of x dx numerically. To evaluate integral a to b f of x dx numerically. Generally, we know how to evaluate integral by using integration formulas. After evaluating integration, we are going to substitute upper limit b minus lower limit a in that function. Then we get the exact value of given integral. That method, using integration, evaluating the integral, is called analytical method, direct method. But the same concept we are going to discuss numerical method, using numerical method. So what is the difference between numerical method and direct method? So here in numerical method, we can evaluate that integral without using single integration formula, without applying any integration formula, without substituting upper and lower limit. We are going to evaluate that integral very easily. That numerical method in every concept is easy to understand, easy to calculate. It will take very less time compared to direct method. In direct method, if you take 10 to 15 minutes to solve this integral, here within 2 minutes you can solve without using integration formulas. But the only one drawback in numerical methods, one demerit is, you will get approximate answer. If you apply integration formulas, if you substitute upper and lower limit, then you will get one answer that is called exact answer. Without applying integration formulas, we are going to use numerical method. You will get answer very quickly in less time, very easy. But only small drawback is you will get approximate answer other than exact, which may be very close to exact value. What I am saying, if one integral value is 4, you may get here 3.8, 3.9 or 4.1 like that. It will approach as exact, but not exact. Sometimes we may get exact value also. Okay, now we are going to know what are the numerical methods to evaluate integral a to b f of x dx. Numerically, we use the following. We use the following numerical methods. Here we are going to use three famous numerical methods. One, Trapezoidal Rule. Number two, Simpson's 1/3 rule. Simpson's 1/3 rule. Simpson's 3/8 rule. So these rules helps us to evaluate integral without using integration formulas. Where we are going to apply these all? What is exact application in engineering? If you come to engineering, especially in civil engineering, surveying is a subject where they will measure the area of a land. To measure the area of a land, they need to integrate. But there they no need to get back the all integration formulas which they learn while studying. They simply apply one of these methods to get the area of one land. Because integration in between two limits represent area. A line integral is a area. Double integral is surface area. A triple integral is volume integral, volume of a solid, 3D figure, 3-dimensional figure. Now we are going to evaluate a line integral, single integral. A single integral means finding area. If you want to find an area of a particular field in surveying, there they won't use these integration techniques. They prefer numerical techniques. They need the answer quickly, approximate area of that field. Then it is much useful subject, numerical integration. Coming to our numerical integration, numerical methods, out of these three, the best method among these three is Simpson's 3/8. Because which gives the answer which is very closer to actual. As I said earlier, these all methods gives approximate answer. These approximate answers are closer to actual. Compared to trapezoidal and Simpson's 1/3 rule, Simpson 3/8 will be very close to actual. For example, 6 is exact answer. If trapezoidal rule gives 4.5 like that, if Simpson 1/3 gives 5.2, Simpson's 3/8 gives 5.9. A better value we will get. Okay, so this method is useful to find this integral value. Coming to what are the formulas we are going to apply? Here are trapezoidal rule formula. What is trapezoidal rule formula? The formula for trapezoidal is integral a to b f of x dx is equal to h by 3 into trapezoidal h by 2 into y naught plus yn plus 2 into y1 y2 so on yn minus 1. So trapezoidal rule, h by 2 sum of first and last plus 2 into sum of remaining y values. Like this one can easily remember. Sum of first and last y values, sum of remaining y values, sum of remaining y values. Coming to Simpson's 1/3 rule. Simpson's 1/3 rule. In Simpson's 1/3 rule, to evaluate integral a to b f of x dx, we are going to use this formula h by 3 into y naught plus yn plus 2 into even suffix y2, y4, y6 so on plus 4 into odd suffix y1, y3, y5 like this. Like this you can remember. These are even suffix, these are odd suffix. This is first and last. First plus last. Simpson's 3/8 rule. What is Simpson's 3/8? In Simpson's 3/8 rule, we are going to evaluate integral a to b f of x dx like this. 3h by 8 into y naught plus yn plus 2 into multiples of 3, 6, 9 like that, y3, y6, y9 so on, plus 3 into remaining y1, y2, y4 remaining. Here 3 multiples remaining. Like this, one can easily remember these all formulas. Very easy to evaluate, everyone can understand. All numerical methods are easy, and this is one of the most important topic in any university exams. You will get definitely an essay type problem. One problem from all these three methods. Evaluate integral 0 to 1 x cube dx by trapezoidal rule. Using trapezoidal rule, we need to evaluate any integral. If you want to evaluate using numerical methods, the step 1 is first write given integral 0 to 1 x cube dx, comparing with integral a to b f of x dx. So first compare this one with this, then you can find what is a and what is b value. A is 0, this is a, this is b. This is a, this is b, this will be f of x. If you compare exactly, you will get f of x is x cube. A is 0, b is 1, f of x is x cube. Now we need to find h. The formula for h is b minus a by n. H is b minus a by n. Here AB values are known, lower and upper integral, limits, lower limit and upper limit. Coming to n, the number of subintervals. If they are given, we will take, otherwise we will take any number between 4 to 12. From 4 to 12, any number you can take it as n, whenever there is no information regarding n. But in our problem, clearly mentioned 5 subintervals. That means n is 5. So what is b? 1 minus 0 by 5. 1 by 5 you will get 0.2 as h. Now we need to prepare a table to evaluate this. Before going to prepare a table, assume for every problem f of x as y. Let y equal to f of x, that equal to x cube. Now remember this very most important point to prepare the table. Whenever you are preparing a table, keep one point in your mind. This table starts with A and ends with B. This is very most important point. Every table in trapezoidal Simpson 3 by 8 starts with A, ends with B. So what is A? A is 0. What is B? B is 1. Starts with A, ends with B. In between A and B, how you are going to get? By adding H. By adding H. What is H? H plays key role. H plays key role to find the table. Add H. What is H? 0.2. Add 0.2 to 0. 0 to 0.2, you will get 0.2. 0.2 plus 0.2, 0.4. 0.4 plus 0.2, 0.6. 0.6 plus 0.2, 0.8. 0.8 plus 0.2, 1. Till you get 1. Now you need to evaluate these values. Y is x cube. Y is x cube. That means 0 cube 0, 1 cube 1. This is 0.2 whole cube. Use your calculator. Without using calc, you cannot solve any numerical method. Calc plays key role. So apply this formula. X cube is given function. 0.2 whole cube you need to find. 0.008 like that. 0.4 whole cube. 0.0064. Sorry, 0.064, right? 0.064. Next. 0.6 whole cube, 0.216. 0.8 whole cube, 0.512. 1 cube 1. So cube all the numbers, you will get like this. Now this will be y0, y1, y2, y3, y4, y5. Keep one point in your mind. If n is 5, this ends with y5. If n is 6, this ends with y6. If n is 7, this value ends with y7. And when n is 5, the total values will be 6. If n is 6, the total values will be 7. If n is 5, 1, 2, 3, 4, 5, 6. And ends with y5. Now, I am going to apply trapezoidal rule. I am going to apply trapezoidal rule to evaluate that integral. Using trapezoidal rule, integral 0 to 1 x cube dx equal to h by 2 first plus last y0 plus y5 plus 2 into remaining y1, y2, y3, y4. H is 0.2, 0.2 by 2, y0 is 0, y5 is 1, plus 2 into y1, 0.008, y2, 0.064, y3, 0.216, y4, 0.512 plus 1. Use calculator to evaluate these all. If you use your calc, you will get 0.26. use calculator. Okay, any doubts you may express? Very easy, very important. Very easy, everyone can understand. Evaluate integral 1 to 2 dx by x by Simpson's rule. Simpson's 1 by 3 rule, or simply Simpson rule, also we treat it as Simpson's 1 by 3. Hence obtain approximate value of log 2. So first what I said, note down given integral 1 by x dx and comparing with integral a to b f of x dx, you will get a1, b2, n is not given, you can take 4 to 12 any value, so I am taking 8. H is b minus a by n, 2 minus 1 by 8, 1 by 8. Use calci. Without using calculator you won't get anything. Using calculator 0.125. By taking f of x as y, evaluate prepare the table. Prepare the table which starts with A, which ends with B. X and Y values. Will starts with A, ends with B. B is 2, A is 1. So by adding H, add H to A, you will get first X value 1.125. Again add 0.125, you will get 1.25. Again add 0.125, 1.375, 1.5. Again add 0.125, you will get 1.625. Again add 0.125, you will get 1.75. Again add 0.125 to this, you will get 1.875. 875. Again add 0.125 to this, you will get 2. Now you need to calculate 1 by x, 1 by 1. This is 1 by 1 value. This is 1 by 2 value. Okay, 1 by 2 value. 1 by 2. Like that, 1 by 1.125, 1 by 1.25. Use your calculator. Without using calci, you cannot start the solution. You have to use your calculator to get the values. From the calculator, this value is 0.48, 0.8, 0.7272, 1.5, 0.46. Up to 4 decimals we are doing problem. That's why I am taking 4 decimals. 0.6153, 0.5714, 0.5333. Now these are notated like this: y0, y1, y2, y3, y4, y5, y6, y7. Because n is 8, you will get up to y8. Now I am going to write Simpson's 1 by 3 rule formula, and substituting these values we will get the answer. Simpson's 1 by 3. From Simpson's 1 by 3, integral 1 to 2 1 by x dx equal to h by 3 into y0 plus y8 plus 2 into even suffix. Even suffix is y2, y4, y6 excluding last one, plus 4 into odd y1, y3, y5, y7, y9. So we don't have y9 up to y7. Now h is 0.125 by 3, y0 plus y8, 1 plus 0.5 plus 2 into y2, y4, y2 is 0.2 plus 0.46 plus y6 0.5714 plus 4 into y1 0.48 plus y3 0.7272, y5 0.6153, y7 0.5333. Like this you need to substitute, but at the end you have to use your calculator. Without using calc you cannot get. So finally by calculating you will get 0.6931. Next our question is find approximate value of log 2. We need to find approximate value of log 2 base e. This value can be evaluated using exact method. So there is an exact method, integral 1 to 2 1 by x dx. You know, integral 1 by x is log x. Integral 1 by x has formula, integral 1 by x is log x. Using this, log x, upper limit 2, lower limit 1. Now write first upper limit 2. Log 2 minus log 1. Without base we treat it as 1. Log 1 any base 0. This value is 0. So this value, if you use your calculator, press log 2 in your calc base e. In few calcs, maximum calculators, log base e is treated as ln, especially in Casio. In Casio, you will have a button ln. Under mode button, you will find ln. Not like this, just like this. ln. Press ln, press 2. You will get exactly 0.6931. So that's what I said. In few cases, we may get the answer like exact. This is exact answer. This is numerical method answer. These two are equal. Okay. If you want, you can check like this also. If you know integration very well, every problem what we are doing here, you can check with actual by doing actual procedure like this.